Hey everyone, welcome to week 9. So this week we are going to talk about an application that you can now do, meaning now that we've done all this coding this quarter, what is something really cool and sort of real world applicable that you can do with all your knowledge. So the specific application we're going to talk about is cryptography. We're going to talk about this one for two different reasons. One, because I think it's really cool and fun and interesting. And two, because when I did my master's program in computer science, I actually studied quite a bit of cryptography. So I thought it'd be fun to sort of bring my personal background and interest into this course, and I think you'll enjoy it as well. So when we talk about cryptography, we're going to talk about a couple different things. We'll first review basic terminology, and then we're going to talk about two ciphers. The two ciphers we'll discuss in this class are the Caesar cipher and the Vigenère cipher. So let's go ahead and get into it. We'll start off with some terminology. So cryptography is the practice and study of techniques for secure communications in the presence of third parties called adversaries. So the way you want to think about it is the adversary is like the bad guy. It's the person that you don't want to know what you're saying. So the situation is, maybe you want to send a message to someone and it needs to be a secret message. So cryptography is the study and practice of basically making messages secret, making them secure so that the adversaries or the bad guys won't be able to read your messages. So again, adversary is basically the person or entity, company, whatever that you want to keep your message secret from. Cryptography started to become really big during the war times. As you can imagine, being able to transmit secret messages to your troops would be very important. You'd want to set it up so that your troops would know how to understand your message, but the opposing side would not be able to understand your message if they were able to intercept it. Alright, so a couple more terminology terms that I want to throw out at you. So encryption is the process of encoding. Now encoding is basically scrambling up the message, so it's jumbling up the message to make it look like something that is nonsense. And again, the idea behind that is you need to do this so that the adversaries will not be able to read it. So encryption is the process of jumbling up your message. Again, so that only the correct people can read it, not the adversaries. Alright, and then on the opposite end of that, we have decryption. So decryption is the process of taking the message that has been jumbled up, the one that's all scrambled and doesn't really make sense, and converting it into something that does make sense. So this is the other end of the process. If you are, the troops that are receiving the jumbled up message, you need to be able to decrypt the message so that you can understand what it said in the first place. So the message before you encrypt it is called the plain text. So plain text is basically the plain old message in English or whatever your natural language is. This is just the standard message, not jumbled up as if you were just sharing it normally. That is what we call the plain text because it's sort of plain, right? There's no jumbled up action happening yet. Then the encrypted version of the message, meaning the message that has been jumbled up, the message that has been scrambled so that only specific people will be able to understand it, that's what we call the ciphertext. So again, some terminology, we have plain text and ciphertext. These terms refer to the message itself, whether it's been scrambled up or not. And then encryption and decryption. Encryption is the process of scrambling up the message. Decryption is the process of basically unscrambling the message back to the plain text. So, you've potentially done this stuff before. If you've ever passed notes in class, in elementary school, maybe you and your friend made up a secret language that only you and your friend would know. That's cryptography. I mean, making up, secret languages like that and different ways to jumble up messages, that is the key part of cryptography. And the idea behind cryptography, again, is to make it so that the adversaries, or the people that you don't want to be able to read your message, you want it so that if they are eventually able to figure out the secret, figure out how to unscramble your message, you basically want to prolong that time. So sort of the number one rule of cryptography is, with an infinite amount of time and resources, the adversary, or the people that you don't want to be able to read your message, they would at some point be able to figure out the secret to decrypt your messages. So the goal of cryptography is basically to make it more complicated so that it takes them a really long time to do that. So like, for example, we'll go back to the wartime example. If you send a message to your troops, potentially the other side might intercept it, and you want to make up a way to jumble that message, to encrypt that message, so that by the time the other side is able to figure out how to decrypt it, the message will no longer be relevant. If you give them instructions about how to prepare for a battle on a specific day, you'd want to make your encryption strong enough so that the opposing troops would not be able to understand the message until, way after that specific day. Alright, so a little bit more terminology. So a cipher is an encryption technique or algorithm. So a cipher is basically setting the rules for how you're going to do the encryption, right? So back to the example where maybe you and a best friend in elementary school made up, a secret language. The cipher would be basically the rules to get from the plain text to the ciphertext. The rules that are set up that take, your standard letters in the English alphabet and translate them to something that looks jumbled up and confusing. So again, the cipher is basically setting up the mathematical rules or the patterns for encrypting and also decrypting a message, right? Because decrypting is going backwards, going the other way. So again, we're going to talk about two ciphers. We'll define them formally and talk about, the algorithm behind them and the code behind them. The two that we're going to cover are the Caesar cipher and the Vigenère cipher. Now that said, with these two sort of basic ciphers, you can then, go off and make up your own ciphers, your own ways to encrypt and decrypt messages. So again, the first one we're going to talk about is the Caesar cipher. This is potentially the simplest cipher. It's also known as the shift cipher. So these two terms can be used interchangeably. It's been named Caesar cipher because the story is that King Caesar made it up. Who knows if that's true or not, but whatever. So the basic way that it works is you have your plain text message, right? And this is your message in plain English or whatever your natural language is. And you take each letter in your plain text and you basically replace that letter with another letter that's some fixed number of positions shifted down the alphabet. So for example, if we're going to use the Caesar cipher to encrypt our plain text, let's say we shift to the right by 3. Alright, so again, the way that it works is you have your standard, A through Z alphabet. Again, this is assuming that the language we're using is English. So that means anytime you have a letter A in your plain text, to encrypt the letter A, you shift down 3 spots the alphabet. So then A becomes D, B becomes E, and W becomes Z. So if we just take a quick look, at an alphabet, here's A. If we shift it over 3 spots, we have 1, 2, 3. That's how we get D. Here's B. If we shift over 3 spots, 1, 2, 3. So B would be encrypted to the letter E, and so on. Now the question is, when we get down here towards the end of the alphabet, how are we going to keep shifting over by 3? Because for example, with the letter Z, if we want to shift over by 3, there's no more letters here. So that is something that you have to sort of think about when you're designing these algorithms, these ciphers. So the standard for handling those letters once you get towards the end of your alphabet is to basically wrap around back to the beginning of the alphabet. So if we again go back to this alphabet here, the letter X, which is right here, if we again are shifting to the right by 3, what we do is go 1, 2, and then 3 all the way back to the beginning of the alphabet. For Y, you would do 1 and then wrap around, 2, 3, so Y would go to B. Z, you go 1, 2, 3, so Z would go to C. So again, the idea is with the shift cipher, you shift to either the right or the left by some fixed number. In this example, we're using 3. And you do have to sort of handle this extra case where if you get to the end, that you're able to wrap around back to the beginning of the alphabet and keep going that way. So a little bit more terminology now that we've talked a little bit about this shift cipher, this Caesar cipher, and what it looks like. So there's another piece of information that will usually come with the plain text. So again, the situation here is you have a message, a plain text, that you want to send to someone else, and to make it secret, you're going to encrypt it first and then send them the ciphertext instead. And then the other person on the other end is going to take the ciphertext, decrypt it, and figure out what the plain text is. So normally when you send to your friend or whatever your encrypted message, the ciphertext, you also send them another piece of information. This piece of information that you send them is the key. And this is going to be some piece of data that specifies the transformation of the plain text to the ciphertext, and vice versa. So the cool thing about using keys is that it gives you a little bit more flexibility with ciphers. It adds just a little bit more depth to them. So the idea is you can use the same cipher with a bunch of different keys. So, you know, if you want to be lazy and just use the same cipher over and over, by introducing a key, you can add in a little bit of difference between each time. So with the Caesar cipher, or the shift cipher, the key is basically the number that specifies how many spots over you're shifting. So with the Caesar shift cipher, in this previous example that we just saw, where we shifted to the right by 3, the key would be the number 3, because that's how far we're shifting to the right. But again, the cool thing about the Caesar cipher is you can shift by any amount, right? You could say, okay, let's shift to the right by 5, in which case the key would be 5. You could also shift to the left. So let's say you wanted to shift to the left by 2. In that case, the key would be -2. All right, so the sort of standard default is if it's a positive integer, you're shifting to the right. If the key is a negative integer, you're going to shift to the left. And that's just because we read from left to right. All right, so just to give you a little bit of practice, I'm going to give you a plain text. So this is a plain text. The plain text here is North, N-O-R-T-H. And I want you to go ahead and figure out what the ciphertext of this is going to be. So meaning the encrypted version, the jumbled up version of this message North, using the Caesar cipher, so the shift cipher that we've been talking about, with the key 5. So I want you to take this word, this plain text North, and to shift over all the letters to the right by 5. So go ahead and do that, and something cool about this is if you finish early, you can check your solution by working backwards, meaning once you have the ciphertext, once you have the jumbled up version, you can then take the jumbled up version and then work backwards so you can decrypt it to make sure you get the original message, the plain text, North, back. So go ahead, pause this video, work on this example, and come back when you are ready to see the solution. Alright, so with this example here, again, we're taking the plain text North, we're applying a Caesar or a shift cipher with key +5. So the solution to this, the ciphertext in this case, is going to be this, STWYM. Really quick, let's just run through this example to make sure we are all on the same page. So again, in this situation, this is our plain text. It is the word north. And what we're going to do is we want to figure out the ciphertext, right? Because we have the plain text and we want to encrypt it to determine the ciphertext. So again, the way we're going to do that, we're using the shift cipher, and the key here is 5, which means we're going to shift in our alphabet to the right by 5 each time. So we'll just go one letter at a time. So we'll start with N, which is right here, and then we're going to shift to the right by 5 spots. So we have 1, 2, 3, 4, 5. So our first letter in the ciphertext is going to be S. Then we'll do our next letter, which is O. So we'll find O in our alphabet, and again, same rules, shift to the right by 5. 1, 2, 3, 4, 5. That'll give us T. We'll do the next one, which is R, which is right here. Shift to the right by 5. 1, 2, 3, 4, 5. That gives us W. Next one is this letter T, right here. 1, 2, 3, 4, 5. That gives us Y. And then the last one, we're running out of colors here. I'll use blue again. The last one is this letter H. And again, we shift to the right by 5. 1, 2, 3, 4, 5. Which gives us the letter M. And as you can see, that's the same solution we got here. Alright, do let me know if you have any questions about this example. Let's do one more example. So this time, the plain text is the word computer, and I want you to apply a Caesar cipher or a shift cipher with the key -4. So again, same thing, pause the video, work out a solution, and then come back when you are ready to see the solution. Alright, so with this one, hopefully you got this. I'll go ahead and work through the first couple of letters just to make sure we're on the same page still. But if you have any questions and you want me to work through more of them, just let me know. I want to open this with, there we go. Alright, so here's our alphabet again. And yes, I do like to write out the entire A through Z alphabet when I work through these problems. It just makes it very easy visually to sort of work through the solutions and to see what's going on. So, you know, on a test situation, very beginning, go ahead and write down this alphabet, all the letters A through Z, and just make sure you have all the letters, right? Because if you write your alphabet incorrectly, you're going to get incorrect results. So just double check your alphabet when you first write it. Alright, so again, this is what we're working with here. We are starting with a plain text, and I know that because it's asking for the encrypted version. So it's expecting me to encrypt something, which means we're going from the plain text to get the ciphertext. So again, plain text here is computer, and we're going to figure out the ciphertext, where the key is -4. So again, the rule is if the key is negative, we'll start with this letter C. If the key is negative, we're going to shift to the left down the alphabet. So again, we're going to shift to the left by 4. So starting with the first letter, which is C, we'll start here. 1, 2, and then we have to wrap around, right? We talked about this wrapped around thing. This will give us 3, 4. So this will give us Y. The next letter, O, we start here, again shift to the left by 4. 1, 2, 3, 4. That gives us K. Next letter we'll do is M. So again, just go in order, letter by letter. So we start here. 1, 2, 3, 4. Gives us I. And I'll do one more. This letter P. We start here. and go to the left by 4. 1, 2, 3, 4, which gives us L. And then to figure out the rest of the letters, you do the same thing, just keep going one letter at a time. So next you do it for the letter U, then T, then E, then R. Again, if you have questions about this example, please let me know. Alright, so before we move on and talk about, now that we've seen some examples on paper by hand how this works, the goal here is eventually to write code that will do this for us, right? That's kind of the point of this class, is that we're going to write code. So I just wanted to really quickly review these stages of programming. This was something that we talked about in week 0, which I know it's been a long time, but this is a good time to review that stuff. So again, keep in mind with the stages of programming, there's often a lot of sort of back and forth. These aren't necessarily stages where you do this, then this, and this, and this, and you're done. Generally, there's some jumping around, but this is the approximate sort of outline of what you're going to do. So the first stage of programming is designing and planning. And again, this is a stage that generally you want to do on paper, or rather without code itself. So this is the stage that can involve algorithm design, which may be making flowcharts or pseudocode or just outlines, whatever works for you. Then write and debugging code, right? We've spent a lot of time this quarter doing that, and as you know, debugging is a large part of that process, and sometimes when you're writing and debugging code, you'll run into, a situation where you have to sort of go back to the drawing board, where you go back to the design and plan phase, and you have to sort of figure things out that you maybe didn't consider the first time around. You also want to test the program, right? Obviously, you want to make sure that not only the program works and it runs, but it also is giving you the correct results. Documenting code, this is something that you should be doing as you are writing code, right? Or even potentially when you first open your file, go through and make some documentation then. And then, of course, this sort of final stage of maintaining code. Now, we haven't had a lot of practice doing this just because this quarter is only, 11 weeks long, but maintaining code is super important, especially if you're publishing code for, the world to use. So again, these are the stages of programming, and the goal that we're going to have today is we're going to take this Caesar cipher that we just talked about, the shift cipher, and we want to write code that will do the encryption for us automatically. So we'll be able to give it a key and a plain text, and it will automatically generate the ciphertext for us. And then also code that goes the other direction, where we give it a key and the ciphertext, the jumbled up version, and it gives us the plain text back, the plain message back. So that's sort of our goal with today. So first, let's talk about designing and planning, and specifically the algorithm. So we've done a couple examples on paper by hand. So I want you to go ahead and take some time now to try to sort of outline these steps that we just did with these examples. So I want you to write down an algorithm for this Caesar cipher that we've just been doing. So the format of your algorithm that you write down, that's kind of up to you. If you want to do like an outline, that's totally fine. If you want to write pseudocode, meaning it's sort of a mix between English and actual Python code, you're welcome to do that. If you're more visual, maybe if you want to do a flowchart or some other diagram, do whatever works for you. However you like to sort of plan out stuff normally. The main sort of key thing about this though is just make sure you're not writing the code yet. So this is sort of the stage where we're planning what we will write in code eventually, but it's sort of just giving us an outline of what to expect. So go ahead, pause this video, take a couple minutes to write down this algorithm, and again, you can refer to those examples that we just did, but you want to try to keep this algorithm general, so it'll work for, any plain text that I give you, any key that I give you. Alright, so hopefully you've taken some time to jot down an algorithm for yourself. I'm going to go ahead and share with you an algorithm that I've written for this. Now, of course, there's no necessarily correct way to write these algorithms so long as they all eventually do the same thing. This was sort of my approach for writing it out. There may be some things that, you explain better or I explain better. Maybe there's things that I didn't cover and so on. And that's totally okay because this is the design and plan phase. This is for yourself and potentially, other team members if you're working on a real world, team environment to sort of plan out how you're eventually going to code stuff. But the cool thing about the design and plan phase is that this is not your final product, right? You can always come back to your outline, your algorithm, and sort of edit it as you go. So here's my initial outline. I tend to have, when I do algorithm design, unless it's like a very involved algorithm with a lot of moving parts, I tend to generally do just sort of a basic outline with maybe a little bit of pseudocode. So you can see in here that I have the word for, right? So that's kind of code like a for loop. And I also like to have my outline set up so that I have indents that sort of represent where I would indent code. So it's kind of like a hybrid between an outline in plain English and a little bit of pseudocode. So this is my sort of outline. And again, this is for taking plain text with a key and converting it to ciphertext using the Caesar cipher. So I said for every letter in the plain text, right? And we saw that, right? When we were going through, we went through each letter one at a time, and then we did stuff with each letter. So for every letter in the plain text, first thing you do is find where it is in the alphabet, right? We had our alphabet up above. Find the letter in the alphabet. Specifically, you're going to calculate its position in the alphabet, right? That sort of translates to, in code, how you would quote-unquote find it in the alphabet. You find its position, calculate its position in the alphabet. Next step, again, this is for each letter, which is why I have all these 4 steps indented. You take this position that you just found, meaning the position of the letter in the alphabet, and then you're going to add the key to this position, right? And this works even with the rule about right and left shifting, right? Because we said with a positive number, you're going to shift to the right, which would basically increase the position. So adding works for that. And then if you get a negative key, you're going to shift to the left, which is sort of decreasing the position in the alphabet. So that would be subtraction, right? But that's the same thing as adding a negative number, so that works. I did sort of add a little note to this. You do have to deal with that wraparound issue that we talked about, right? When you run out of letters, you need to be able to wrap back around to the beginning of the alphabet or the end, depending on which direction you're going. So when you're in the design and planning phase, it's totally okay to, make note of things that you are going to have to deal with, but you're not sure how to deal with yet. It's totally fine to do that. Again, this planning, designing phase, this is for you. This is for you to plan out. So if there's something that you're sort of stumped by, you're not sure how you're going to handle this particular thing, just sort of make a note saying, hey, I know I need to do this. I don't know how to do it yet. Like I did here. Somehow deal with this wraparound issue. That's totally fine to do. All right, so after you add the key to the position, then what you're going to do is you're going to look up what letter is at this new position in the alphabet, right? You have a letter, you find its position in the alphabet, add the key to that position, which is basically the movement of shifting down to find the new letter, and then we put this new letter into the ciphertext. So the idea with this algorithm is for every letter in the plain text, we're going to build up one letter at a time, a letter in the ciphertext. So again, this is my sort of first pass through writing an algorithm of this. I would recommend, maybe comparing this to what you just wrote. Note if there's any differences. Again, yours might be better than mine. That's totally fine, Maybe there's something that I wrote here that, you wrote in a different way. That's also totally fine. I would just recommend, just sort of comparing and contrasting and making note of similarities and also maybe differences.